Hello and welcome to your lecture on probability. In this lesson, your objectives are to be able to use words associated with probability, such as fair, even, certain, unlikely, and so on. Represent and compare probabilities on a probability scale from 0 to 1. Use probabilities written as fractions, decimals, and percentages. List the outcomes of single events and find their probabilities. Understand the terms mutually exclusive and exhaustive. Find the missing probability from a table. Know that the P, or the probability of event not happening, equals 1. Take away the probability of an event happening. Use relative frequency to estimate probability. Estimate the number of successes based on probability. Understand that a larger number of trials results in a better estimate of probability. Represent outcomes of two events, example throwing two coins in a sample space diagram or a list. Apply systematic listing strategies, including the product rule for counting. Understand what is meant by independent and conditional probability. And use frequency trees to find the probabilities associated with single events, along with drawing a tree diagram to show probabilities of two events. Okay, so that sounds like quite a lot, but it shouldn't actually take us too long to go over this. So let's get a move on. So, the probability scale. Now, the probability scale is a way that we can express probabilities. The probability of something is the chance or likelihood that something will happen, and all probabilities lie between 0, which is classed as impossible, and 1, which is certain, and they can be written as fractions, decimals, or percentages. So here we've got a normal probability scale, and we've expressed some probabilities in words. So at this end of the probability scale, we have impossible, and at this end we have certain. In the middle would be an even chance, and then probably unlikely and likely, just like this. We can add in numbers, so 0 for impossible, 0.5 for even chance, and 1 for certain. Just going to rub those out so you can see the numbers. Okay, so we've popped those in. Now, we could probably put a lot on this probability scale that you would have to do in foundation and be absolutely fine just knowing that. But we do need to make sure that we know a few other things. So if we look at this other probability scale, impossible would still be 0, even chance would still be 0.5, and certain would still be 1. But we could also label unlikely and likely as 0.25 and 0.75. And remember, they're written as 25% and 75%. This would also be 50%. This would be 100%. And this would be 0%. So what you're saying here is that if something's certain, there's a 100% chance that it'll happen. Okay? Now, don't forget, we also need to know that these are or can be written as fractions. 0.25 is the same as a quarter, 0.5 is the same as a half, and 0.75 is the same as 3/4. So in your exam, you might be asked to put certain things on a probability scale using these values. Okay, so let's look at an example then. A bag contains 3 red footballs, 3 blue footballs, and 6 green footballs. Mark these probabilities on the probability scale. So A, the probability of choosing a green football. So when we work out probabilities, we need to know how many of one thing there are and then how many there are in total. It says here that there are 6 green footballs, 6. But we need to write that out of the total. Well, we've got 3 red and 3 blue. So that's 12 in total. We've got 3, 6, and then another 6 there, which is 12. So if we add them all together, it makes 12. So 6 out of 12 can actually be cancelled down to a half, because 6 is half of 12. So the probability of P, okay, the probability of choosing a green football would go here in the middle, P. Okay, I might just put it there as well, so we've got it in both. Then says the probability of choosing a red football. Well, there are 3 red footballs out of 12. And if we cancel that down, so here what we did was we just realised that 6 was half of 12, but you could have said that you divided by 6. 6 divided by 6 is 1, and 12 divided by 6 is 2. Whereas with the probability of choosing a red, 3 out of 12 would have to divide by 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So that's a quarter. So remember, a quarter is going to go just here. Okay, so that would be the T, probability of choosing a red. So T would go there. Okay. Now, if you've not got your number line labelled in the exam, then you're going to have to label it like this. But it's pretty straightforward. Okay, so it's like we split it into the 4 parts. Okay, we know that that's a quarter, a half, and 3/4. Then the last one says, work out the probability of choosing a black football. Well, the question says there are 3 red, 3 blue, and 6 green. There are no black footballs. So the probability of X choosing a black football would be 0, so we'd pop it on like that. Okay, so using a probability scale isn't too difficult. Right, let's move on to calculating probabilities associated with single events then. So as I've just mentioned whilst doing the probability scales, that when we write a probability, we need to know the number of ways it can happen, and that's over the top of the total number of outcomes, the complete total. Okay, so for example, if we had 12 footballs in total, that's what goes on the bottom, and the probability of picking a red was 3. Okay, so the probability of something happening is the number of ways an event can happen over the total number of outcomes possible. Now, what you need to remember is we've got exhaustive events, okay, and exhaustive events account for all possible outcomes. For example, 1, 2, 3, 4, 5, and 6 are all possible outcomes when a dice is thrown. The total probability of exhaustive events is 1, and I'll explain that in a bit more detail in a second, okay? By 1, they mean like 100%, okay? Mutually exclusive events are events that cannot happen at the same time. For example, throwing a head and a tail on a fair coin cannot appear at the same time, okay? So you just need to know the difference between exhaustive events and mutually exclusive events. Now then, let's look at a question. The letters in the word mathematics are placed in a container and a letter is taken out at random. What is the probability that it is a T, an S, or an R? Now, if you'd like to pause the video and have a go at this question, please do that now and then press play for the answers. Okay, if you've had a go at those then. Now then, first of all, question A, the probability of choosing a T. Well, first of all, let's look how many T's there are. There's one there and one there. So that's 2 T's out of, and then we've just got to count how many letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 2 out of a total of 11. The probability of choosing a 2 is the number of ways an event could happen, so T comes up twice, over the top of the total number of outcomes, which is 11. The probability of choosing an S, well, we've only got one S, so that'll just be 1 out of 11. And then C, the probability of choosing an R, well, there is no R's in mathematics, so the answer would be 0. Okay, so when you're doing probability, try and remember that it's this to work out single events. Okay? Okay, let's have a look at another question. A card is taken at random from a shuffled pack of ordinary playing cards. Find the probability that the card is A, red, B, a heart, or C, the 10 of clubs. Oh, sorry, 1, 2, or 3. Explain why your answers to part 2 and 3 are mutually exclusive. Okay, so again, if you'd like to pause the video and press play for the answer. Okay, if you've had a go. Okay, so a card is taken at random from a shuffled pack of ordinary playing cards. Now, this question is quite common, But kids these days, teenagers these days, don't always know how many cards are in a pack. And there are 52 cards in a pack of playing cards. Okay? The probability of you choosing red is actually half of the pack of cards, because half of the pack are black and half are red. So that would be a half or 50%. It depends how you want to write it. Then it says the probability of finding a heart. Okay. Now again, when you have a pack of cards, there are hearts. I'm going to just explain this now because you might get it in your exam. Hearts, diamonds, spades, and clubs. Okay. So hearts, diamonds, spades, which I'm not very good at writing, and clubs. I think they look like this. I forget. I haven't played cards for a while either. Okay, so you've got your 4 types of card there. There's 52 cards in a pack. These 2 are red. Okay, and these 2 are black. Alright, so you've got 26 black cards and 26 red cards, because there's 52 cards altogether. Half are red, half are black, and half of 52 is 26. Then, because there's 26 in each colour, we have 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Okay, so your probability of choosing a heart is 13 out of 52. But if you've noticed, it's actually a quarter. Okay, because half of the cards are red, if you see there. And if we half it again, it's 13, which are hearts. So 13 out of 52 is actually a quarter. You could also show that if we divide it by 13, okay, 13 divided by 13 is 1, and 52 divided by 13 is 4. Okay, so choosing a heart is a quarter, but that's also the same for choosing a diamond, choosing a spade, and choosing a club. Alright? Now another thing to explain is that within each set of cards, within each suit, okay, so in the hearts, diamonds, in spades, we have ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So in every suit there is only one number. So there's the 1 of hearts, okay, well it's an ace, sorry. So then there's the 2 of hearts, 3 of hearts, 4 of hearts, and so on for all of the suits. Okay, so question 3 says, what's the probability of choosing the 10 of clubs? Well, there's only 1 10 of clubs in a pack out of 52. Okay. Now it then says to explain why your answer is mutually exclusive, why your answers to part 2 and 3 are mutually exclusive. You can't get a heart and a club at the same time. So if you pick a card out, yeah, you cannot draw a heart and a club at the same time, because they're 2 separate things. Okay, so you could say, if you picked a card at random, it's impossible to pick a heart and a club at the same time. Okay, so that's why they're mutually exclusive. All right, I hope that made sense. I know it's a lot of information to take in for just one question, but it's because I need you to be able to understand playing cards really in order to get the answers right in the exam. Okay, let's move on then. So, now then, earlier on I mentioned that the probabilities of an event happening and not happening are mutually exclusive. Okay, just put a T there, event, sorry. And exhaustive, so the possibilities add up to 1. Now, what that means is that when you know the probability that an event will happen, you can calculate the probability that the event will not happen using this formula. Okay, so what I'm saying here is the chances of, let's say, for example, the chances of you being late to school are 0.5. What are the chances of you being on time is also 0.5. Because 0.5 add 0.5 make one whole one. You can also say it's like 50% plus 50%, which equals 100%. So what you need to remember is that all probabilities add up to 1, okay, when it comes to exhaustive events. Now, that will probably be very common in your exam, so just try to remember that all probabilities add to 1. Okay, so this seems like a little bit of a funny formula here, but basically the probability that an event will not happen is 1, take away the probability that the event will happen. Okay, you'll see what I mean in a second. So let's look at this example. The probability that an alarm clock goes off is 0.79. What is the probability that it will not go off? Well, all you've got to do is do one whole one, and you're going to take away the 0.79 to let you know what's left. Okay, another way you could do that is 100 take away 79, because we've written them as percentages. Okay, which leaves us with 21%, or 0.21. Okay, so either of those is correct. The probability that it will not go off is 21%, or 0.21. So all you're doing is working out what's left up to 1, because all probabilities add up to 1. Okay? Right. Let's look at this example then. Here's your formula, but again, it's up to you how you're going to remember this. The probability that a 17-year-old passes their driving test on the first attempt is 3/7. What is the probability that they do not pass their driving test on the first attempt? Now this time it's been written as a fraction for you. If anything, that makes it a bit easier maybe. Depends on how you look at it. Alright, now if you're not sure about fractions, what it's saying here is that the probability that this 17-year-old passes is 3 out of 7. That means if we drew that as a diagram, now I'm sorry, but this is not going to be very good. 1, 2, 3, 4, 5, 6, 7-ish. They should be equal. The probability that he passes is 1, 2, 3 out of 7. That means the probability that he doesn't pass, in order to get a whole one, is 1, 2, 3, 4 out of 7. Okay, because 3 over 7 plus 4 out of 7 is 7 out of 7, which is one whole one. Okay, if we changed all of these to decimals, okay, which means you'd put them in your calculator, probably give you some random numbers like 0. something really long, but you could do that, and you added them together, it would still give you 1. Okay, so when you're given a fraction, okay, so in this case they said it was 3/7 that he will pass. Oops, sorry, 3/7, not 3/4. Don't know why I did that. Okay, it's 3/7 that he'll pass. What's left from 3 up to 7 is 4. So 4 out of 7 is what you need to make a whole one. So that's the probability that he will not pass. Okay? Alright, why don't you pause the video and have a go at this next question. So, Imran throws a dart at a target. The table shows information about the probability of each possible score. Imran is 4 times more likely to score 2 points than to score 1 point. Work out the value of x. So if you'd like to pause the video and have a go at this one, please go ahead and do that. Okay, if you've had a go at that then, what we're going to do here is, what we need to remember is that all of these probabilities in these boxes, they all add up to 1. Okay, so what we need to do to work out what x is, or 4x is, okay, we need to add them all together. So we're going to do 0.05 plus x plus 4x plus 0.23 plus 0.19 plus 0.28. And all together they should equal 1. So for now, I'm just going to put my x's to one side. I've got 5x altogether. And then I'm going to add up all the numbers. And if I add up all those numbers, you should get 0.75. That means that 5x plus 0.75 equals 1. Because all probabilities add up to 1. Now what you've got here is an equation. 5x plus 0.75 equals 1. If you wanted to write this in a way that you understood it, you could say 5x plus 75 equals 100, because you can say that these are percentages instead. Okay, so 5x plus 75% equals 100%. And to work out 5x, we need to rearrange this equation, don't we? We need to work backwards to find out what x is, get x on its own. So I'm going to subtract 75 from both sides so that I can get 5x on its own. That leaves me with 5x on this side equals 25% on this side. Because 100 take away 75 is 25. If I did that to this side, I would take away 0.75. Okay, that leaves me with 5x equals 0.25. It's exactly the same, we're just doing one as a decimal and one as a percentage. And then to get x on its own, this is 5 times x, so we need to divide by 5. Okay, that gives us x equals 5%. If I divided by 5 here, it would give me x equals 0.05. Okay, lovely. So it might be easier for you to work in percentages, that's fine. But if your answer requires you to answer as a decimal, we need to put it back as a decimal at the end. I'll show you how to do that. So we now know that x is 5%. X equals 5% or 0.05. Okay, so I'm just going to rub this bit out. It does only say to work out the value of x, so we've technically done that. Alright, hope you're taking lots of notes because I need to rub this out. But what we're going to do now is we're going to work out the probability of scoring a 1 and the probability of scoring a 2. Okay, that's what we're going to do now. So, the probability of scoring a 1 is x. Okay, that means that the probability of scoring a 1, let me get a pen, probability scoring a 1 equals 5% or 0.05, because x is this value here, we've just worked it out. The probability of scoring a 2 is 4x, which is 4 times 5%. Okay, 4 times 5 is 20, so it's 20%. But like I say, if it wants your answer as a decimal, we should know that 20% is written as 0.2. Okay, so there you have it, done. You do need to be quite good at writing numbers as fractions, decimals and percentages. If these were fractions, this would be written as a fifth. Okay, this would be written as 1 out of 20. But you most likely won't be asked to do that. Okay? Alright, let's have a look at some experimental probability now. Experimental probability is determined by the result of a number of trials or events, okay? And this is called relative frequency. So for example, if I wanted to work out the probability of you catching a ball, I would have to throw a ball to you quite a few times before I came up with a general probability of the likelihood of you catching that ball next time. So, relative frequency of an event is the number of favourable outcomes over the number of trials. So this is exactly the same, really, as probability. How many times did something happen out of the total number of times you carried out the experiment? So, for example, a dice is rolled 55 times. A 4 is rolled 13 times during these rolls. The relative frequency of scoring a 4 would be 13 out of 55. Now you could also write that as a decimal, because you could use that line meaning divide, and you could do 13 divided by 55 on your calculator, and it gives you 0.23636364. And we could say that's 0.24 to 2 decimal places if we wanted to. But you can leave things as fractions. The more times the experiment is carried out, the closer the relative frequency is to the theoretical probability. Okay, so theoretical probability analyses a situation mathematically. And basically what it means is that if I threw a ball to you 100 times and you caught it 74 times, that would be a 74 out of 100 or 74% chance that you will catch the ball. However, if I threw the ball to you 200 times and you caught it 80 times out of those 200, then that's only an 80 out of 200%, 80 out of 200 or 40% chance of you actually catching the ball. So the more times we do the experiment, the more accurate that relative frequency or that probability is. Okay. Now then, we have a question here. So I've given you your relative frequency formula. So all of these little formulas you could do with, making sure you've got some notes on these. All right, you've been given 3 so far. Now it says below here, the frequency table shows the results of throwing a fair coin 100 times. What is the probability of a head? Now, you can pause the video and have a go at this one if you like, but it's not too tricky. The probability of getting a head is 48 times out of 100, because that's how many times they threw it. Okay, so we could write it like that, but then we can cancel down as well, giving us 24 over 50 or 12 over 25. So we would have a relative frequency of 12 over 25. Remember, to simplify fractions, I'm just dividing by a common number and not common factor. If you're not confident with cancelling down fractions, then go back and watch the video on that. Okay? Okay, so now then, again, looking at your relative frequency formula, you can use probability to predict the outcome of an event. Okay, expected number of outcomes equals the number of trials times the probability. Now, basically, what I'm saying here is that let's say you've worked out a relative frequency, and I know that the chances of me catching a ball is 24 times out of 100. Okay, that's 24% or 0.24. Okay, that's my relative frequency. That's my experimental probability. That's the percentage of times I think you're going to catch that ball. And then let's say, because I've got this, okay, I'm now going to do a separate experiment, and I'm going to throw the ball to you 200 times. What's my experimental probability, or what is my probability that you will catch that ball? Well, I would actually just work out 24% of 200, okay, or I can times it by 0.24, all right, because what you're saying is that, well, I think you're going to catch that 24% of the time, which means I think you're going to catch that 48 times out of 200. Okay, so sometimes when you're given a relative frequency already, you can work out how many times you think someone is going to do something. For example, this question here. The probability of passing a biology exam is 0.73. If 100 people take the exam, how many would you expect to pass? Okay, so what we do is, this is a very simple question though because of the numbers that are being used, is that there are 100 people sitting the exam, and I think that 0.73 or 73% will pass. Okay, so basically I need to know 73% of 100. Well, percent means out of 100 anyway, so if I times it by 0.73, it will just give me 73. So I think 73 students will pass. Okay, it's because we've used 100 students that's made that easier. If 200 students took the exam, okay, and the probability of them passing is 73%, I would times that by 0.73, or I would find 73% of it. Okay, and that will tell me that I think 146 students will pass out of 200. Okay, so when you're asked a question like that, all you're going to do is the expected number of outcomes that you expect is the number of trials, so like this number here, times the probability. But when I say times, it must be in decimal form, because otherwise you'll get a really high answer. Alright, so if they give it you as a percentage, make sure you write it as a decimal. Okay, so 36% would be 0.36 and so on. Sorry, that says 0.24. Okay, so make sure you write that as a decimal. Let's do another example just so you feel confident. The probability that Alex is late for work is 0.2. He has 40 working days until his next holiday. How many days can Alex's boss expect him to be late before his next holiday? Okay, so the probability that Alex is late is 0.2, and he's got 40 days left to work. So if you'd like to pause the video and have a go at that, then go on and then press play for the answer. Okay, so remember, what it's saying is the probability that he's late is 0.2 or 20%. Okay, so, and he's got 40 days of work left. So you're going to do 40 and you're going to times that by 0.2. Technically what you're doing is finding 20% of 40. Okay, so 40 times 0.2 is 8. So he's going to be late for 8 of those days. Okay, and that's basically how you work that out. Now then, when we look at possible outcomes for 2 or more events, it gets a little bit not necessarily confusing, and I think a lot of you do actually quite well at these questions. Okay, so you need to be able to find all the possible outcomes of multiple events in order to calculate the probability of any one of these outcomes. You can do this using an ordered list, a sample space diagram, or a two-way table. You can also use the product rule for counting to find the total number of possibilities without writing them all down. But what that basically means is, okay, if you're going to use a list, you must write a list in an ordered way to make sure that you include all the possibilities. So, for example, you have got a menu here, and it says, what are the meal combinations for a 2-course meal from this menu? Okay, so this is a very common question. And all you need to do is think, what are the different combinations of ordering food? Okay, so you can order pizza and yogurt. You can order chicken pie and yogurt, and you could order fish and yogurt. Okay, then you could order pizza and cake, chicken pie and cake, fish and cake. They're the options for the 2 courses. Okay, so now that you've written all of those down, what I want you to tell me is, out of those options, what's the probability that you choose a menu or a 2-course meal that includes pizza? Okay, so all you would do is, in your exam, if they ask you to write down all the possibilities, then you do this. Okay, and then if it asks you a question, you would then answer it. So the probability of you ordering a pizza would be 2 out of 6, because 2 of the options involve pizza out of 6 options, which can then be cancelled down to 1 out of 3. Okay, now the product rule for counting can also be used to find the total number of possible combinations. Okay, now for example, if there are A ways of doing task 1 and B ways of doing task 2, there are A times B ways of doing both. Okay, so what you could have done with the menu, okay, let me just show you that menu again. There are 3 different main courses and 2 different desserts, which means you know that you need to have 6 different combinations, because you would end up doing 3 times 2. Alright, So let me just read that again. If there are A ways of doing task 1 and B ways of doing task 2, there are A times B ways of doing both. So you would multiply both amounts, giving you 6 different combinations. Okay. However, this is very rare. Your main task in the foundation will be to write a list of options. Okay, that comes up quite regularly. Now then, here is a two-way table. Okay, the two-way table shows the genders and handedness of students in a class. What is the probability? All right, there you go. What is the probability that a person chosen at random is right-handed? And then question B says, if a boy is chosen at random, what is the probability that he is left-handed? Now, in your exam, you most likely will be given a two-way table. You might have to complete the table, but then they'll ask you questions on it, okay? Now, the table won't be difficult to complete because most of the time you'll be given totals or certain numbers which will then lead you to be able to complete it, all right? And a lot of you are very good at that, so I'm not going to go through that right now. The probability that a person chosen at random is right-handed. So pause the video and have a go at these if you want to. And if a boy chosen at random, what is the probability that he is left-handed, okay? And then press play for the answer. Okay, if you've had a go at that then. The probability that a person chosen at random is right-handed. Well, there are 24 people that are right-handed, okay? 24 people, out of a total of 33 people. And we can't cancel that fraction down. And if we wrote it as a decimal, it would probably give us quite a long answer. Let's just check. 24 divided by 33, yes, gives us 0.727272. So we can leave it as a fraction, that's fine. If a boy is chosen at random, what's the probability that he is left-handed? So what we're going to do is we're going to go to the boys column. We're going to look at the left-handed one, which is 2, and it's 2 out of 33. Okay, that's out of the total people. However, it says if a boy is chosen at random. So actually it'd be 2 out of 16 because there's 16 males in total. So rather than it being 2 out of 33, be very careful because it's saying if a boy is chosen. So boys, total boys is 16 total boys. Okay, we can actually cancel that down to 1 over 8 because we can divide by 2 on the top and the bottom. Okay, sample space diagrams then. Now, these are quite good. So sample space diagrams are particularly useful when there are several options for each event. Okay, so here are 2 spinners. Okay, and they're spun and the scores are added together. And then you've got a bunch of questions here. Now this is where you will have to draw the sample space diagram. Okay, so what it's telling you is, and I'll start you off here, but then I've got it on the next page. You've got on the first spinner, we can have spinner 1. Okay, and then spinner 2 here. Alright, and if you want to, you can have a go at doing this. And the scores are added together. Alright, so what you're saying is that if we spin this one and we get a score, and then we spin this one and we get a score, they're then added together. Okay, so on the first spinner, you've got 1, 2, and 3. And on the second spinner, you've got 2, 3, and 3. Okay, so if we got a 1 on the first spinner and a 2 on the second spinner, that gives us 3 because we're adding them. If we've got a 2 on the first spinner and a 2 on the second spinner, it would give us a 4. And then if we've got 3 on the first spinner and 2 on the second, it would give us a 5. So then what you would do is you just go through and complete the table. Okay? And then you've got a bunch of questions. So why don't you pause the video, have a go at completing the table and answering the questions, and then press play and I'll go through it. Okay, if you've had a go at that, here is my two-way table. Alright, and I've added them all together and put them in nicely. So A was to show the outcomes on a sample space diagram. You've already done that. B says, what is the probability of a total score of 4? So what we do is we go onto the table and we look at all the values where we got 4. Okay, so that we got 4 3 times. And altogether, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 options. 9 scores altogether, so it's 3 out of 9. We can actually cancel that down by dividing by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. So B is 1/3. The next question says, what is the probability that the total score is an odd number? Now, if we look at our grid, how many odd numbers do we have? We've got 1 there, 1 there, 1 there, 1 there. So that gives us 4. 1, 2, 3, 4, out of a total of 9. And we can't cancel that down because 4 and 9 don't have a common factor. So there, you've done. So that's how you would use sample space diagrams. Not too tricky, hey? Okay, so now what we're going to do is we are going to look at the probabilities of multiple events and using tree diagrams. Now, there are 2 important rules for calculating probabilities of multiple events depending on the type of event. Remember that 2 or more events are independent when the outcomes of the second event is not affected by the outcome of the first event. Okay, so for example, flipping a coin and rolling a dice, they don't affect each other. So these 2 rules, the OR rule. If 2 events are mutually exclusive, the probability of A or B happening is found by adding the probabilities. Okay, so for the probability of A or B, we add them together. Okay. Whereas the AND rule suggests that if 2 events are independent, the probability of A and B happening together is found by multiplying the separate probabilities. Okay? So if they're mutually exclusive, we add, and if they're independent, we times. Now, we can write that like that. The probability of A and B equals A times B. And frequency trees are used to show the outcomes of these 2 events. So, looking at this example question then, a shop employs 80 people. 40% work part-time, the rest work full-time. 17 part-time staff and 27 full-time staff are male. I want you to draw a frequency tree to show the information and then work out the probability that a worker chosen at random is female. So you've got quite a bit to do in that question. So why don't you pause the video and have a go at it and then press play and I'll go through the answer. Okay, if you've had a go. Now, first of all, the question gives us a percentage, which means we're going to have to do some work on percentages before we even get to doing the probability. It says that the shop employs 80 people. So we start our frequency tree by putting 80 in a circle. Then it says that we've got 40% work part-time and the rest work full-time. So we're going to need part-time staff and full-time staff. We need to work out 40% of 80 in order to find the part-time staff. So we can do 0.4 times 80 here. So if you remember from our percentages lesson, to find 40%, we can turn it into a decimal, which is 0.4, and times it by the number we need the 40% of. And that gives us 32. So 32 members of staff work part-time, and 80 take away 32 is 48. So 48 people work full-time. Okay, so we've worked that out. Then it says that 17 part-time staff and 27 full-time staff are male. So that means we need to now show male and female. Okay, so it says 17 staff are part-time, 17 male staff, and 27 male staff are full-time. So out of the 32 part-time staff, if 17 are male, 32 take away 17 is 15. So that will be 15 female part-time staff. And then 48 people work full-time, 27 are male, and 48 take away 27 is 21. So that's 21 female. So there you go, you've done A. You've drawn your frequency tree. And now you can use it to work out probabilities. Okay? Now then, this one isn't too bad at all. What is the probability that a worker chosen at random is female? A worker chosen at random is female. So what we do is we count up all the female members of staff. We have 15 females there and 21 there. So that makes 36 females in total. And because we're talking about the entire cohort of workers, which is 80 people, it would be 36 out of 80. Okay? And you could even say something like the probability of being female is 36 out of 80. And you could probably cancel that to 9 over 20. Okay? Because we can divide by 4 to get the simplest form. Okay, so I hope that made sense. So that's how you would draw a frequency tree. Okay, and now what we're going to do is look at this question, which is going to help us draw a tree diagram. So you can also use tree diagrams to show the outcomes of events and to support calculating probabilities. The probabilities on the branches leaving each point on a tree must add up to 1. So here's an example question. A bag contains 3 red counters and 4 blue counters. A counter is taken from the bag at random. Its colour is noted and it is put back in the bag. That's very important to note, that it's put back in the bag. Okay, because it's saying here you've got 3 red and 4 blue counters. Well, that's 7 counters in total. Okay, so if you chose a blue, the probability of choosing blue is 4 out of 7 because there's 4 blue counters. And if you chose a blue and then you put it back, you've still got 7 counters. But if you chose a blue and you didn't put it back, now there's only 6 counters. So you'd have to put 6 on the bottom. So you must remember when you're reading it whether it's said that you're putting it back or not. Okay? And then it says a second counter is then taken out of the bag. Draw a tree diagram to represent these events. That's A. And then B, work out the probability of picking 2 blues or 1 of each colour. Okay, if you want to have a go at drawing the tree diagram, press pause and then press play and I'll go through it. Okay, so we have to take our time here because we don't want to make any mistakes. It says that we have 3 red and 4 blue counters. Okay, 3 red, 4 blue. So what we do is we put red and blue like this with little branches. The probability of picking red is 3 out of 7 because 3 add 4 is 7, so there's a total of 7 counters. 3 are red, 4 are blue. So the probability of picking a blue is 4 out of 7. So let's say we put our hand in the bag and we choose a colour. We then put it back in. Okay? If we put it back in, we're then going to do a second attempt because it says a second counter is then taken out of the bag. That means we need to do this again. This time, if I chose red the first time, my second attempt I would need red and blue again because I don't know what I would choose. And if I chose blue the first time, I would need red and blue again because I didn't know what I've chosen. Okay? So now what we've done is we've drawn a tree diagram that represents 2 attempts of putting your hand in the bag and collecting a counter. Okay, so you've drawn the tree diagram. The hard bit's over. This is 3/7, this is 4/7, and the same would be here and here and here and here. Because you're not keeping the counter, you're putting it back. So 7 would remain on the bottom of the fractions all the way through. So then it says, what's the probability of picking 2 blues? Okay, well, the probability of picking 2 blues is going to be, if we pick blue on the first attempt, that's 4 out of 7. And we pick blue on the second attempt, oops, sorry, that's not blue. And we pick blue on the second attempt, that's also 4/7. So what we do is when we use a tree diagram, we multiply. These are independent events because we've not taken the, we've put the counter back. All right, so we multiply them. Okay, That gives us 4 times 4, which is 16, and 7 times 7, which is 49. So that is the chance of picking out, that is the probability of picking out 2 blues. Now the next question says, what's the probability of choosing one of each colour? Okay. Now, choosing one of each colour means you could either choose red the first time and blue the second time, or you could have chosen blue the first time and red the second time. So that means, I wonder if I can do it in these colours. That means that I could have chose blue-red, the probability of blue. That colour looks terrible. Okay, let's do it in this colour. That means I could have chosen, if we look at this first one here where I chose red first and then blue, okay? I could have chosen the probability of red times the probability of blue. I could have done it that way around, okay? Which is why I would do 3/7 times 4/7, giving me 12/49. Or I could have ended up doing blue first and then red, which means probability of blue multiplied the probability of red. That would give me 4/7 times 3/7, which gives me 12/49. Okay, so basically there are 2 options to choose one of each colour. So now that I have worked out my multiplications and it's given me these 2 fractions, what I actually need to do is work out the full probability of choosing one of each colour. Okay, and the full probability of choosing one of each colour means I need to add those 2 fractions together that I worked out. Okay, because there's more of a chance that I'm going to get one of each colour. Because there's 2 ways of doing it, okay? So that means I'm going to end up with 24/49 as my probability. Because I just add, remember when we add fractions, we just add the 2 top numbers if the bottom numbers are the same. All right, so that's how you would do the second one of each colour. Because you can't just say, well, I could choose red then blue, because you might not have chose red then blue. You might have chose blue then red. It's all about what you could have chosen. We're not actually sitting here doing the experiment. Okay, so I hope that makes sense. All right, so from all of that then, I'm hoping you are okay using words and a probability scale, as well as discussing probability as fractions, decimals, and percentages. Single events, mutually exclusive and exhaustive, understanding that, which I think you do now. You can find the missing probability from a table. You can work out an event not happening when you've been given the event happening, or vice versa. You can use relative frequency to estimate probability, and I hope you can estimate the number of successes based on probability. You can also understand a large number of trials result in a better estimate of probability. So I only went through that kind of slightly, but basically the more trials of something you do, the better, the probability will be, or the more accurate, should I say. You can represent outcomes of 2 events using a sample space diagram, and you can write things in lists, including the product rule for counting. You should now understand the difference between independent and conditional probability, and use frequency trees and tree diagrams to write out probabilities and to answer questions based on them. Okay, that was a lot of things to go through today. I hope you found it interesting and informative, and good luck in your assignments. I really look forward to seeing how you do. I'll see you in the next video.